Korea's first commercial nuclear reactor, the Gori-1, which operated for 40 years, is set to become history. The government has approved its decommissioning, marking the country's first ever approval for nuclear dismantling. While many are optimistic that the growing global nuclear dismantling market could become a new economic driver for Korea, concerns also remain over the safety of this pioneering endeavor. In today's Zoom In segment, we take a closer look at the process, the significance, and the challenges surrounding the Gori-1 retirement. For this, we're now joined by Professor Cheong Jae-hak at the Kyung Hee University's Department of Nuclear Engineering. Good morning and welcome to the show.
Okay, good morning. How are you?
I'm doing, I usually sound better, I promise, but thank you for joining us.
Thank you for having me today.
Of course. This is a time-sensitive topic, so we had to get onto it rather quickly. For our listeners, maybe you can begin with the basics of the dismantling steps. So Gori-1 unit is projected to be fully dismantled by the year 2037, with costs estimated at over 1 trillion won. Can you first, for our listeners, break down the expected procedures by stages?
Yes, absolutely. The decommissioning of a nuclear reactor like Gori-1 involves multiple carefully planned stages that typically span a few decades. As you know, on June the 26th, the Korean government officially approved the decommissioning plan for the Gori-1. And Gori-1 is the first nuclear power plant in Korea. With this government approval, the preparation and planning phase, which has been underway since the permanent shutdown of Gori-1 since 2016, can now be considered complete. So during this phase, a wide range of activities were carried out, including the development of detailed decommissioning plan and safety assessment and environmental impact assessment, and various radiation surveys and communication with the local communities. Then the next step might be the dismantling and decontamination. And in this phase, structures, systems, and components that have been contaminated with radioactive material will be removed, and any radioactive contamination will be thoroughly cleaned. This significantly reduces the radiation level at the site and prepares it for the further work. The next stage is safe management of various decommissioning waste to be generated from dismantling and decontamination activities. And then the final stage of decommissioning is site restoration. So after dismantling and the decontamination work, residual land or buildings can be reused for any purposes like industrial sites or a new site for constructing new nuclear power plants. For the case of Korean Nuclear Power Plant Unit 1, the entire process is expected to be completed by the year 2037. I mean, it will take about 12 years from now, and it will cost about 1 trillion Korean won.
Professor Cheong, it seems one of the key questions we must ask is how to safely dispose of radioactive waste. Just a quick search will tell you the gold standard today in different parts of the world is interim dry storage for high-level waste and maybe geological repositories for final disposal. So we have to ask you, more than 171,000 tons of radioactive waste is estimated to be generated from the Gori-1 dismantling, but the disposal plan for now remains rather unclear. So what options are currently under consideration? And in your view, which is the most viable option?
Yeah, that's a very important question for safe and safe decommissioning of nuclear power plants. You know that during the decommissioning process of power plants, various types of waste are to be generated, including the concrete and metals, which were used for the construction and operation of the power plants. As you already mentioned, that for Gori-1 is expected to be generate more than 171,000 tons of radioactive waste. Therefore, the strategy for the safe management of decommissioning waste is very crucial. All waste streams are sorted by type and radioactivity level, It is then safely treated, packaged, and then stored on site in line with appropriate national regulations. The radioactive waste that requires further control is ultimately sent to the radioactive waste disposal facilities now in operation in Gyeongju, the area for the permanent disposal. Among the various types of waste, the intermediate level, the radioactive waste, is planned to be transferred to the rock carbon type final disposal facility, which is already operated by Korea Radioactive Waste Agency in Gyeongju area. And the lower level, the radioactive waste is to be disposed of in the near surface disposal facility, which is currently under construction also in Gyeongju area and scheduled to begin its operation next year. And meanwhile, the very low-level radioactive waste will be disposed of in a landfill-type disposal facility, but it is currently being planned by the Korea Radioactive Waste Agency. On the other hand, very, very slightly contaminated waste can be released from the nuclear regulatory control and managed in the same way as non-radioactive waste.
In separate to the radioactive waste that you just explained how it will be properly disposed of, there's also the question around nuclear fuel. Nearly 170 tons of spent nuclear fuel is also expected to be generated from the decommissioning process. Can you explain how spent nuclear fuel maybe differs from general radioactive waste and share insights on how the spent fuel is expected to be managed?
Okay, I'd like to say that the spent nuclear fuel still contains valuable fissile materials such as plutonium, and which can be used for the new fuel after reprocessing. However, once the spent nuclear fuel is decided to be disposed of, then after that it is treated as radioactive waste and ultimately destined for deep geological disposal. Currently, Korean official policy is not to reprocess spent nuclear fuel, but to directly dispose of the spent nuclear fuel in deep geological repository. As you mentioned, approximately 170 tons of spent nuclear fuel currently stored in the spent fuel pool of Gori-1 will be transferred to dry storage facilities, which is to be newly constructed on site in a few years. And where this spent nuclear fuel will remain for a certain period, I think about a few decades, even after completion of the decommissioning work. Subsequently, the spent nuclear fuel stored in the dry storage facility is expected to be transported to the off-site interim storage facility under development, and eventually it should be sent to the deep geological repository for final disposal.
As far
Notably,
please go on. Sorry.
Notably, a new special act on high-level waste management aimed at ensuring the long-term safe management of spent fuel was passed by the National Assembly in February this year and promulgated in March and scheduled to be enforced in September this year. Under this legislation, the Korean government aims to secure an interim storage facility by 2050 and the final repository by 2060. So, yeah, in conclusion, I think the spent fuel generated from Gori-Unit 1 will be stored on site temporarily and then sent to the interim storage offsite, and then finally it will be sent to the off-site deep geological disposal facilities. But both facilities will be constructed in maybe 20 years later or 30 years later. So we have to wait for the final solution for spent nuclear fuel.
And in that given time period, I suppose more construction will take place, as you've already mentioned. But can technology be driven forward? Because from what we understand, there's clearly a demand and a need for these dismantlement, not just in Korea, but across the globe. And it's not just Korea racing to deal with dismantlement. From what I understand, the IAEA estimates that by 2050, around 600 nuclear reactors would need to be dismantled. So the nuclear decommissioning industry currently lacks a global leader. And the question is, can Korea fill that void? How do you evaluate Korea's capabilities in nuclear decommissioning going forward?
So you know that starting with the Gori-1, the Korea has accumulated vast experiences in construction and operation of a total of 28 nuclear power plants, and is currently the fifth largest nuclear power operating country in the world wide. That said, while Korea possesses a strong potential and technological capabilities, it is still in an early stage of full-scale commercial nuclear power plant decommissioning. But I'd like to say that over the past few decades, Korea has been developing various decommissioning technologies through a project related to decommissioning of small research reactors. In fact, Korea has successfully completed the decommissioning of small-scale nuclear facilities, including research reactors and small uranium conversion plants. In addition, Korea established the Korea Research Institute of Decommissioning, so-called KREED, in 2020 as a dedicated organization for leading the development, demonstration, and infrastructure support for safe decommissioning technologies. Both the government and private sectors are investing in advancing these technologies in order to ensure safer and more cost-effective decommissioning practices. In summary, I can say that although Korea does not yet have experience in dismantling of large-scale commercial nuclear power plants, we have already secured the necessary technologies and capabilities for the safe decommissioning. Through continuous technology development, I believe that Korea is expected to achieve decommissioning methods that are both safer and most cost-effective.
Mm-hmm. Then, Professor Jung, based on your expertise, do you think Korea can secure a position as one of the market leaders in this decommissioning market valued at up to 500 trillion won? And if we still have many steps to take, what further efforts are required to clinch that leadership position?
I think that in order to become the market leader in decommissioning of nuclear power plants, we must first prove our self domestically by safe and efficient decommissioning of Gori-1 and sharing the lessons learned. This success will serve as a showcase for Korean technology and project management capabilities for the safe and efficient decommissioning. Second, we must leverage a wide range of fourth industrial revolution technologies in order to accelerate the development of zero-risk decommissioning solutions, enabling safer and more cost-effective dismantling of nuclear facilities. For example, advanced dismantling robotics and waste volume reduction technologies and automated radiation monitoring systems connected with drones and robots can significantly enhance the efficiency and the safety of nuclear decommissioning. Thirdly, I can say that we need to establish a national strategy for global market entry, including partnerships with firms and governments abroad, and participation in international projects, and a stronger presence in global fora like the IAEA and OECD Nuclear Energy Agency. If we combine the technical excellence with the safety and transparency, then I confirm that Korea could definitely take a leading role in this emerging global market.
You've talked about transparency, you talked about cost effectiveness, but I think the key word that you continue to highlight when it comes to these nuclear reactor dismantlement conversation is absolutely safety first. And you've highlighted that several times again. We'll wait and see what comes next in this chapter. This may sound a little bit off topic, but it was in our headlines. So we want to get to this final question today while we have you. How concerned are you about recent reports that North Korea has been discharging wastewater directly into a nearby river for quite some time, contaminating our West Sea? It's believed to have contaminated some parts of our waters. What is your understanding?
Well, while this topic is not directly related to today's topic on the nuclear decommissioning, but it may raise some environmental and public health concerns. So, in accordance with the recent report, they suggest that North Korea has been discharging wastewater, potentially containing radioactive substances, into the river that eventually flows into the West Sea of the Korean Peninsula. This has alarmed many people in Korea. That is a fact. However, at this stage, I think we still lack independent and scientific the actual data on what exactly is in that wastewater. The level of radioactivity, if any, needs to be further verified through some monitoring efforts. Although the information is quite limited, even if the wastewater was actually released to the sea from the uranium refining process, it is expected to contain only naturally occurring radionuclides from uranium decay series. The radiotoxicity of natural uranium is relatively low compared to some notorious artificial radionuclides like cesium or plutonium, so which are released during the nuclear power plant's accidents or the reprocessing of a spent nuclear fuel. In this context, I believe that the Korean government's recent decision to collect actual environmental samples, such as seawater or river water from the areas near the Pyeongsan uranium refining facility in North Korea, which may include the Han River estuary or the Ganghwa Island, to test for the radioactive materials such as uranium, cesium, and even including some other types of heavy metals. It is very appropriate measure to help to ease unnecessary public concern about this issue. I would also like to emphasize that in response to the discharge of contaminated water from the Fukushima Daiichi nuclear power plants into the Pacific Ocean, at the time, the government's efforts to strengthen the environmental radiation monitoring in the surrounding seas have played a very important role in minimizing unnecessary public concern.
Yeah.
So we must stay alert, gather accurate scientific data, and then respond calmly but firmly based on science, not just speculation.
Professor Chung, because we've seen the topic be politicized before, and that's not the point. We should rely on scientific data. We can't highlight that enough. We thank you so much for your insights and joining us so early in the morning. Thank you very much.
Thank you for having me today.
It was our pleasure. We spoke to Professor Cheong Jae-hak at Kyung Hee University's Department of Nuclear Engineering. If you're listening to our program using the podcast service, just a reminder that we do go live Monday through Friday, 7 a.m. Korea Standard Time. So tune in and help us make the show more informative by giving us your input. See you bright and early on Good Morning Seoul.